All right. So I'm just gonna give you a formula, and I'm gonna give you a breakdown of things. You want me to show you the 8-step idiot-proof way to do it? I will show you that way. But most of you guys need starting by understanding. Last year, I get a watermelon, I cut it, I rotate them with a chopstick. Yes, and Aiden, you're gonna see that later. I'm not gonna do that for BC because that's too much time, too much preparation. I had to find a watermelon during the winter time. It's very difficult.
Watermelon.
Huh?
I have like small watermelons.
HMAR.
Oh, we saw. Oh no, Mr. Yang. My brother found a video of you doing that for his AP class the other day.
Oh, really?
Yeah, we found his recording.
All right, so there's something called disk method. And there is something called washer method. And we are gonna learn shell method on the block period. Shell method is actually pretty interesting. A lot of people will actually end up shell method better than the disk and washer. What?
This is fun. Washer's not.
Okay. No, sometimes this can be hard too, but it depends on if you understand the last concept. So this method is gonna be. Let me talk. It's gonna be r squared of x dx between a to b, and there's a pi outside. And the last year, a lot of people forgot pi. I'd have to take a half points off on every single questions. So hopefully you're not one of those students forget pi, but pi is very, very important. Now you're gonna say, where is this equation come from? It's actually pi r squared. Why is pi r squared? We're gonna explain to you. But there is a vertical, so this is a vertical spinning, like vertical orientation. There's a horizontal orientation is a pi, c to d, obviously different values, and the r squared of y, dy. So this is a horizontal cross section. So there is a disk and washer. Now washer is actually coming from, instead of pi r squared, so pi r squared like this, like I can find the area of a disk. Well, this disk is gonna have a radius, so that's equal to pi r squared. But a washer method is like a washer. Now a lot of people thought it's a washing machine washer when I talked about washer method last year. How many people thought it's washer?
Is it like the washer that you put like a screw in?
Yeah. So this is the washer of the screw. Okay. And oops, this is not centered, but anyway, you get the idea. That's uncalled for.
Are you making fun of his eye?
I'm gonna tell Tanya. All right, so I hear, guys, I hear if you want to find out the area of this, obviously it has a bigger radius and smaller radius. So a lot of misconception is this. And this is a misconception. This is wrong, by the way. The big R minus small r squared. This is wrong. This is the wrong way to do it. Why is wrong with this? You want to find out a bigger area, subtract the small area. So the correct way, it should have been this. Okay, so this is not correct. A lot of misconception is not the difference between bigger radius and small radius square is actually the big radius square minus small radius square. Because essentially, if you distribute it, right, it's gonna be pi r squared minus the pi r squared, which is the area of the empty circle subtract from the area of the bigger circle. And this will be a correct way to approach this. So it's called washer method. We are using the washer to find out the value of certain things. Now, what we're gonna do is we're gonna write down the equation. Equation same like before, it's pi. And this is gonna be r squared of x minus r squared of x dx between a to b. This is a vertical one. There's a horizontal one. It's gonna be c to d of r squared of y. That means a function in term of y, by the way, minus r squared of y dy in pi. So basically, you are learning this method and washer method today. Yes.
That's the r of x is just the function for the line because that would be the radius.
The function of a radius.
Yes.
Yeah, so radius changing throughout the time. So I'm gonna show you example. So start with the example. Example that you can go in. Hopefully you have this. So this is this method. This is this method. This is orientation. You can show you the orientation. This is a view. So this is where they cross. So let's change this to, let's say, just this. This is square root x graph. So basically, square root x kind of look like a bullet, like a half of a bullet, right? So if I change this orientation a little bit, then I can show you how do they rotate. So that's I'm gonna rotate here. Oops, this way. So if I rotate, it's gonna form a like kind of like a bullet shapes. But on the side, you see it's a circle. Now, how do I see that? Let's just say if I change this to, let's say, just one slice. Let's say A is let's say 3.9. So basically, it's gonna form this disk, and this disk is different disk throughout from 4 all the way to 0. Because if you go in from, let's just say from 0 to let's say 0.4, this disk is gonna be a little bit smaller. Does that make sense? So it basically is like cucumber. You take a cucumber and you dice it up. No, you slice it. No, you dice. No, you dice. Sorry. You slice. Okay, you slice really fast, like what Brendan's doing. Sushi chef. All the Fucanese child knows. All the Futonese child knows restaurant business. Jenny, do you know how to do that? You know how to do that? Brendan, you know how to do that? The walk? That's a hard work. It is heavy. I don't know how they do it. It's very heavy. All right, so so we're gonna give you an example. The example is same thing as square root of x. And this square root x, if I were to do here, the graph will look like something like this. I'm gonna exaggerate a little bit. So 1, 2, 3, 4. It's gonna look like this. And we're gonna cut off at x equal to 4. So x equal to 4 right here. And then y equal to 0. So it's gonna cut off. Okay. Now this is the first time Aiden see this. So if you don't understand, let me know, please. I have no idea if you understand or not. So we're rotating this graph across the x-axis. Does that make sense? So let me see. We can do this. So basically you just rotate them like this. Imagine they are only halfway, so I can rotate it. I wish I can break this to half. But it's rotating. It's basically, it's gonna form a shape like circular shape. If you cut it this way, it's gonna be all circular disc. Is that okay? So now, so for example, if you have disc right here, and this disc is gonna look like a much bigger compared to this disc here. Does that make sense? So every disc has different radius. And it's gonna form this kind of shapes. So basically we are gonna form the shapes here. So this is a bigger disc. If you come into here, it's gonna go from here, it's gonna create a small disc. From here it's gonna be a smaller disc, from here it's gonna be a smaller disc. So we are basically adding up each individual disc by using integrations. So how do we do this? We can take this function, we can say, okay, well, this is the radius, right? And radius length, you get it from y equal to square root x. Does that make sense? So if I want to calculate the area of this disk, it's basically a sum, which is integral, like summation, sum, between 0 to 4 of all different kind of disks with all different kind of radius. Well, the radius based on what? Square root of x, right? This is r of x. Does that make sense? And then square, and times dx, and don't forget pi. And this is how you find the volume of that disk. So this is disk method. Okay, there's another one called washer method. Now, how does the washer method work? The best way I can think of it is take this same function, and I'm rotating, instead of x, I'm rotating across the y. So here's the thing. Last year, I told you guys to visualize the shape. A lot of people cannot visualize the shape. So let's say if I rotating this way, what kind of shape would it be?
Be like a funnel. It's like an upside down umbrella.
Well, the funnel is not wrong, but that's not what a shape look like.
It's like when you push an umbrella.
You know one of those?
Yeah.
You know one of those sheet like those things you put like a quarter in and it rolls down the floor.
Yes, not a machine, but
He's ignoring us.
I'm sorry, but if you go to Orlando Science Center, there was a place that you can throw the marble, and they will go in cycle to show the gravities. It looks like that.
Like if you push an umbrella down umbrella, it goes like this. It's like this. It's like this. It's like this.
No, it's not like
I
that.
think it's smaller at the bottom. Yeah. It's just an upside down umbrella. It's like round, but it's like.
Okay. I don't know what you're talking about, but okay. So I'm gonna try to draw it. Shh. So this side of the graph, so it's like a big cylinder. So start looking at the cylinder first. The cylinder is based from this rotation. This line, if you rotate around just based on using that line, it's gonna give me a big cylinder. And last year I say it looks kind of like a bun cake. A little bit like a bun cake.
That's what I was describing. It was like this.
Okay, so shh. Now there is a dip section like this. This, whatever you carve out, is like a spin top that you can throw on the ground and can. I don't know if you guys have a spin top, but whatever you carve out is spin top. So let me talk. Unless you want to talk, unless you want to explain it, because I don't know if I can do a good job. So if you can do a better job, I will let you talk. So first thing is you find the volume of a cylinder first. And you find out the volume of the spin top. And then you subtract them. And that's why if you have a cross section, let's just say if I have this bun cake, right? And if I just cut it in this way, and just that one small slice, you're gonna see a bigger radius circle and there's a small radius circle. Small radius circle is gonna be the hollow spot, where the no cake is. If I just cut it directly, only cut one slice from here to here, just one slice here and one slice here, it's gonna give you a bigger circle and small circle. Small circle is gonna be hollow, which is the hollow part is gonna represent the spin top part. So then you go ahead, you say, okay, well, how do I find the volume of this? This you had to use washer method. This you had to use washer method. So do you guys still remember how to find the volume of this?
The big R is the. No.
No, the big R is the.
So first of all, between 0 to what? 0 to 4 or 0 to 2? 0 to 2, because you are going to stop right here. And the way you're doing calculation is going to be this way, right? So you're going to add up all the infinite amount of slices from all the way to up. So that's going to be 0 to 2 pi. 0 to 2 pi. Now what's the big R?
It's the, I don't know.
Big R is not y squared.
That
Four.
Yeah.
Big R is 4.
4 minus 2x. Or y squared.
4 squared minus what?
Y squared.
Minus what? Y squared squared.
Oh, Josh, yes.
Okay, so that becomes a washer because y squared is this distance right here. Okay, Aiden, are you completely lost?
The formula makes
The formula says r squared, but this is the r. Okay, so I'm gonna go through it. I'm gonna go through an 8-step idiot-proof way. It takes me 6 years to come up with this 8 steps. You can use it or you don't want to use it, doesn't matter. I'm gonna show you the 8 steps, kind of idiot-proof. Like, you know how like in some scientific class they ask you to make a sandwich, a peanut butter sandwich, and you have to write an instruction to put on the sandwich, like put a peanut butter on the sandwich, and you put on top the whole bread of.
And that one video was like, you put the knife in the peanut butter jar and it just grabs the end of the knife, drops in the jar, and you go.
No, that
Who did that? Yeah. All right. So this 8 steps come out with this, and I actually forgot about 8 step. I actually could borrow Emily's notes. So Emily's notes that she copied from last year, I'm gonna just write it down for you. First step is always draw the bounded graph. Okay, that's the first step. Always draw the bounded graph. Now, even though it's 8 steps, it's not as hard. You don't have to write 8 different things. No, you actually just jot down what is the things that you need to draw. Okay. Now, second, I want you to draw the axis of rotation. Very, very important. Very, very important. Draw the axis of rotation. So you're gonna denote as like this. This is just say that part is rotating. The third step is gonna be, it has to be in one direction. draw from, and you have to start from here. It has to be from here. From axis of rotation to the boundaries. Now it could be S, could be pro. If it's two boundary, it's gonna be washer. Is one bound, it's gonna be. So is one bound usually represents disk. If it's a two bound, then that's gonna be a washer. Okay, so if you draw, and I'll show you how to do that in a second. So that's like a very, very important thing. Decide are they disk or washer. The fourth step is gonna be deciding dx or dy. Now it depends on your slice. If your slice is vertical, then it's dx. So this is a vertical, and this is a horizontal. Okay, so this is the fourth step. Even though there's a lot of steps here, it doesn't take a long time. 5. You have to decide the correct boundaries. So sometimes it's very important. From 1 to 2 or 3 to 4, you have to figure out what a boundary is. The 6th step is, if it's a disk, you're gonna find only big R of X or R of Y. It could be in terms of Y, so that means you have to solve for X. If it's a washer, then you have to find two things. You have to find a big R of X and small R of X, or big R of Y, small R of Y. 7, which is very crucial stuff, is even today I make a mistake on the question. Step 7 is don't forget pi, because I forgot pi and all my fifth period students laugh at me. And I even write it beforehand, said don't forget pi. Don't forget dx or dy. And don't forget square. If you need a square, so for example, like this square is very important. If that square is not there, that means your answer is wrong. So if this square is here, it need to be there, it need to be there. So that's why it's so easy to make mistake. Last one is very, very crucial. Last one I'm gonna write in purple here. This is a very, very confusing idea, which is when you deal with off-axis rotation, this is actually kind of difficult. So if you ever have y equal to something, let's say y equal to x squared, so y equal to something, or f of x equal to something, this represents the distance from x-axis to boundary. And if you got x equal to, or f of y is equal to, this means distance from y-axis to the boundary. So you're gonna say like there's 8 different steps. There must be a lot of writing. It's actually not. Because the whole idea, you just have to set up and solve. Set up and solve, using decimals to solve. And you can get it done very quickly. So I'm gonna show you a question. Same question, if you have y equal to square root x equal to 4, y equal to 0. So there's a boundary. Now it's rotating about x equal to 4. What kind of shape if I rotate around x equal to 4? It's what? Okay, what does it look like? Oh, hamburger bun. Hi, Mom. Okay, so I want you to figure out this equation among you guys and see if you guys can figure out this. Brandon, wake up. Remember last year I asked you 12 different rotation? You had to figure out all 12. Benicia, remember that. Benicia's trying to erase from her memory.
Like this.
Yeah, that's why you should do this.
You have to borrow one.
Yes.
Well,
Thank you.
If you finish, raise your hand, I'll come check. Everybody finish? You don't have to set up, you don't have to evaluate. Is what right? No. So first of all, I'm gonna ask you, is that the equity one?
It's just changing that you can only. No, I'm going to change it, yes. It's not hard. I do this. Your boundaries are. Your boundaries are all wherever you are, right? So you're going from, like, can I see what you? So if you're rotating this weird. No, but it's this.
It's intuitive.
But it's
Or your body.
Oh my god, you're right. No, you're not gonna do that.
Okay.
Like zero, right? So what is your
This is perfection.
So instead of a different.
Why? We just want to criticize you for watching.
I didn't find it.
What if you don't mind?
The former doctor was short.
This is all this work.
It might.
You're rotating on eight.
This makes sense. Wait.
It's a.
And it's from dirty.
Oh, that's right. For the.
You only want the inside of it.
Part two. Oh, girl.
Are you playing ping pong?
No.
Huh? Are you playing ping pong?
After school? or West Oak.
West Oak.
Yeah, I'm gonna take my kids. We are trying to training for a tournament next Friday.
Oh my god. You can't serve like that though, because you have to put it on a table.
Break you down. Oh yeah.
But it has to go over the net.
That's too high.
Yeah.
Your ball's gonna bounce too high.
Okay, we need to go to class. I'll see you later.
I'll see you at West Oak. I'm not be at West Oak around like 4:30.
Okay.